Hi guys. So today we are going to review some topics from Algebra 1 and look at a couple things a little bit more in depth. What we're going to look at today is a lot of things from quadratics that you did in Algebra 1. So when it comes to quadratics, one of the most important things for us to really understand is factoring. Factoring is really important. It's going to come up a lot throughout this year and a lot in your future math classes. So when it comes to factoring, what you need to make sure of, your first step is always to take your GCF. After you've taken your GCF, then how you move on really depends on how many terms you have. If you have two terms, then there's a couple things we look for. The first thing we look is to see if we know the square root of both those terms. So if we know the square root of both terms, then I can separate that if there's subtraction. So if I have something in this form where I know the square root of both terms and there's minus in the middle, then this can factor into a plus b, a minus b. And that's called a difference of squares. This is something that's really common, and it's going to come up a few times throughout the year and just through a lot of different factoring. So this is something where if you can recognize it, it's really easy to factor, but it's really important that you're able to recognize this when we have it. The other type of squares, if you have addition, you need to make sure that does not factor. Okay, so a squared plus b squared does not factor. Right, the other thing we can look at is if we know the cube root of both terms. So if I know the cube root of both terms, that can be either addition or subtraction. It does not matter which, it'll just look a little bit different. So what we do, this factors, it's important to know it does not factor into any form like this. Okay, you will not see a factor that is to the third power. The way that this factors, it factors into a binomial and then a trinomial. The way we get the binomial is we just take the cube root of both terms. To get the trinomial, there's a little acronym we can use called SCUMS. The U is just to help us remember the word SCUMS. The U doesn't actually stand for anything. But what SCUMS stands for, what we do is we're going to square the first thing that I wrote. So I'm going to square the first. Then I'm going to change the sign, then I'm going to multiply, and then I'm going to square the last. So that is your sum of cubes formula. Now that acronym still works if it's subtraction. So to start, the binomial would just be a minus b. And then again, we square the first, we change the sign, multiply, square the last. So that's difference of cubes. When it comes to three terms, there's a couple different types of questions you'll see. The first one, if a is 1, okay, so something like x squared minus 2x plus whatever it is, that is an example of kind of your easy questions. Okay, if a is 1, these are the ones we need to be able to do quickly. These are the ones we need to be able to just look at it and find what those numbers are. And we'll do a couple examples here later. If a is not 1, that's when it gets a little bit harder. So if a is not 1, the method you probably saw in Algebra 1 was that you split the middle term, and then you did grouping. And that's the method I'll show you for a couple of these examples. Some of you, though, depending on how often you factored, you may just kind of guess and check to find these values. And if that works for you and you can get these successfully, you are welcome to keep doing it that way. And it actually is going to be a little bit faster. The last thing with three terms that, again, can save you some time is if you can recognize a perfect square trinomial. So a perfect square trinomial is something in the form of ax squared plus abx plus b squared. Oops, sorry, plus 2abx. So if we have a quadratic that's in that form, that is going to factor into your, and it could be plus or minus, into that binomial squared. Okay, so the binomial is actually being squared. Again, this is one, if you recognize it, it could save you time. But the biggest thing I want you guys to realize is that there is a difference between this perfect square and a difference of squares. Those are not the same concept. A difference of squares is where you start, where you know the square root. So something like x squared minus 16. That's an example of a difference of squares. A perfect square trinomial, if it's in the factored form, is like x plus 1 squared. And then that multiplies and FOILs out into a trinomial. So it is different. right, the last thing we consider is if there's 4 terms. So if you have 4 terms, then the method we're going to use today is grouping. Later on this year, we're also going to learn something called the rational root theorem. But we're not going to look at that until we get into polynomials. All right, so now let's look at factoring. So again, first step whenever we factor is to first take our GCF. So in this case, this first one, there is not a GCF. Then we know that there's 2 terms. It's 2 terms. We know the square root of both terms, so that is a difference of squares. So that factors into 7x plus 8, 7x minus 8. So again, if you can recognize that difference of squares, it's going to save you a lot of time. All right, next one, there is no GCF, and with this time we know the cube root of both of those values. So the cube root of both of those values would be x plus 5. That's the binomial. Now I'm going to get the trinomial. So the trinomial, I would do square the first, change the sign, multiply, and square the last. As long as you've taken out your GCF, this part is not going to factor any farther. All right, and number 3, this is an example of why you have to do the GCF first. This actually is a difference of cubes, but right now it's hard to see. So I have to take my GCF first. And now it's a difference of cubes. So I could do 3 minus x, and then square the first, change the sign, multiply, and square the last. All right, number 4, there's actually a couple different ways that you could work this out. So I'm going to start by working this out using that split the middle method, which is the longer method, which is a way that a lot of you may have seen this in Algebra 1. So this method, if you did in Algebra 1, what you did was you multiplied the first and the last terms together. And then you looked for something that multiplied to that number and also added to the middle number. Well, in this case, what multiplies to 36 and adds to negative 12 would be negative 6x. So what I do is I rewrite the problem with those numbers. Then from here, I'm going to do grouping. So I'm going to group these first 2 together. I'm going to take out what's common from those 2 terms, which is 3x, which leaves me with 3x minus 2. Then I'm going to look at the next 2 terms. The sign that's there, I'm going to keep that sign. 2 is common. I'm left with 3x minus 2. So now my last step, whatever's in the parentheses, if that matches, that's my first factor. Everything that's not in the parentheses is my second factor. So that's kind of your long method for this. Now, a couple things about this to consider. When we were looking for numbers that multiplied to 36, what we need to consider, we were actually looking for numbers that multiplied to 36x squared and added to negative 12x. So it's important to consider your variables here because these variables are going to change here in a little bit. All right, now the other way that you could have worked this question out is you could have recognized that this is a perfect square trinomial. Because if I take the square root of the first and the square root of the last, that's 3 and 2. And if I times that by 2, I get that middle term. So that is a perfect square trinomial. So this is 3x minus 2 squared. On these perfect square trinomials, the sign in the middle is going to be the same as the sign on that b term. All right, so let's look at a couple more. So number 5, again, we can go through this the long way or we can go through this by guess and check. I'm going to go through this one the longer way. So what I would do here, again, multiply those together. I'm looking for something that multiplies to negative 90 x squared y squared. And then I'm looking for something that adds to xy. Well, the numbers that multiply to negative 90 are going to be 10 and negative 9. But those terms are going to stay xy because 10xy, if I go ahead and split that middle, whoops, I left off my 9. All right, so if I do 10xy minus 9xy, it is still the same as 1xy. But when I actually multiply them together, it would be x squared, y squared, which is, again, what I get when I multiply those terms together. So now I'm going to go ahead and do my grouping. So 2x comes out. I'm left with 3x plus 5y. Do the grouping on the next two. Minus 3y comes out. I'm left with 3x plus 5y. What's in the parentheses is my first factor. Everything else is my second factor. All right, number 6. Number 6 is actually a difference of cubes. We do not need to FOIL that term out because we know the cube root of c plus d cubed is c plus d. The cube root of 27 is 3. So your first term here is just the c plus d. So when I square the first, I'm squaring c plus d. So square the first, change the sign, multiply, and square the last. And then if you want to FOIL this out, you can. And I could make that c squared plus 2cd plus d squared. And I get my final, that full big long thing. All right, so now let's look at this last one, number 7. So number 7 is an example of a difference of squares. I know the square root of both those terms. The square root of x to the 4th is x squared. So x squared minus 4, x squared plus 4. This is not fully factored, however, because x squared minus 4 is again a difference of squares. So that becomes x plus 2, x minus 2, then x squared plus 4. And that is the fully factored answer here. Remember, again, the sum of squares does not factor. It has to be a difference of squares. Cubes, it can be either way, but squares, it has to be subtraction. All right, so let's look at 8 and 9. If you feel pretty comfortable, pause the video and try 8 and 9. All right, so looking at 8. So again, this one, I need these to multiply to negative 24x to the 4th. Adds to a negative 5x squared. So that's going to be a negative 8x squared and a positive 3x squared. So I'm going to split my middle. 2x squared comes out. 3 comes out. So I get 2x squared plus 3 and x squared minus 4. And then to fully factor, 2x squared plus 3 will stay, but x squared minus 4 becomes x plus 2, x minus 2. All right, then looking at 9. This is a 4 term, so we have to use grouping here. Okay, so again, I'm going to look at my first two. X cubed comes out. I'm going to look at my next two. Negative 1 comes out. So this becomes x cubed minus 1 and x squared minus 4. Now again, this is not fully factored at this point. To fully factor, x cubed minus 1 becomes a difference of cubes. So square the first, change the sign, multiply. I don't know why I wrote x. Square the last. X squared minus 4 becomes x plus 2, x minus 2. All right, 10 is probably one of the hardest ones just because it's kind of hard to see. We are going to use grouping on 10, but if you notice, if I try grouping the way I've grouped already, it's not going to work because there's nothing that's going to be the same. So what I actually have to do for 10 in order to group this is I want to group these 3 terms together, because those 3 terms are actually a perfect square trinomial. That factors into x plus y squared. Well, now what I have left, I have a difference of squares. The square root of that first term is x plus y, so x plus y minus z, and x plus y plus z. And that one, it's not that the actual math there is hard, it's really hard to see though that this step is going to factor into a perfect square trinomial. All right, so now what we're going to look at is just using factoring to solve. So again, pretty similar, we're just going to add one extra step. When you solve by factoring, it has to equal 0. Okay, it has to equal 0. So this is the difference of squares. So 2x minus 5, 2x plus 5. And then I just set each factor equal to 0 to actually get my zeros. So in this case, I would get x equals 5 over 2 and x equals negative 5 over 2. So those are the actual zeros and the solutions to this equation. On b, again, I have to set it equal to 0 first. This is a perfect square trinomial, so this is x plus 3 squared. So the only solution here is negative 3. What that also means is that's where your vertex would be, since there's only one solution. All right, on C, again, I can factor this the long way, or I also could use guess and check to factor. So if that's the method you're using, the way we do this, basically I need these two numbers should be multiples of 6. These two numbers should multiply to be 12. So let's say I try for 6, I do 3x and 2x. Then I also need numbers that multiply to 12. So let's say I did 4 and 3. What I really need to do then, I know that this is 12 and this is 6. What I need to check then are my middles. So I need these middles to become a negative 17x. Well, if this is a negative and this is a negative, I get negative 8x on the inside, negative 9x on the outside, which adds to a negative 17x. What you can also consider, the same method we've been using, where if I did this times this, what multiplied to 72 and added to negative 17, those values that I'm getting, negative 8 and negative 9, those are the same values that I'm getting right there. Okay, so you can also use that kind of as an intermediate step if you need it to find your values. All right, and then from here, again, I need to solve. So my solutions, I would get x equals 4/3 and x equals 3 over 2. All right, so that's it for the factoring. Now, we are going to review just a couple other things with quadratics, just to kind of make the rest of these days a little bit easier. So with quadratics, some forms of quadratics that you learned about. Standard form, ax squared plus bx plus c. That's your standard form for a quadratic. Vertex form, you did x minus h squared plus k. Your vertex was hk. Then you also have the root or factored form. So you would have a, and then you have x minus the root, and then x minus the other root. Those are your three forms of a quadratic. The vertex, in vertex form, that vertex is hk. The other way you can find the vertex, if it's in standard form, negative b over 2a will give you the x-coordinate, and then you would plug that in to get the y-coordinate. Axis of symmetry is just where the x-coordinate of the vertex is. So it's either h if you're in vertex form, or if you're in standard form, it's the negative b over 2a. All right, so to get from standard form to vertex form, we need to use completing the square. So the way completing the square works, what we do is we need to figure out what number can I add to those terms to give me a perfect square trinomial. The way I find that number is I take the middle value, the b, I divide it by 2, and then I square it. So 4 divided by 2 squared is 4. Now to keep this equation the same though, if I add 4 to that side of the equation, I also have to subtract 4 from that side of the equation. The other thing I could do if I wanted is I could add it over here as well, but we won't do that unless we get to solving. The reason I picked that value is because it factors nicely into x plus 2 squared, and then I just simplify the right side, and now this equation's in vertex form. All right, looking at b. So this gives me a value that's greater than 1. So if the a value is greater than 1, what we need to do is factor it out for the first two terms. So I'm still going to leave my blank. To figure out what goes in the blank, I'm going to take the middle number, divide it by 2, which is 2, and square it, which is 4. But what I'm actually subtracting now, I'm not going to subtract 4. I'm going to subtract 3 times 4, because that's really what's being added to that equation. So now I end up with my vertex form. You can also use completing the square to solve. Very similar process. It's just what I usually do then is instead of just separating this value out, I'm actually going to move it to the other side because it's going to need to be there eventually anyway in order to be able to solve. So in order to solve, I take the middle number, I divide it by 2, and I square it. So 8 divided by 2 is 4, 4 squared is 16. If I add 16 to the left, I also add 16 to the right. Now the left side factors. And now to solve, I can start by taking a square root. Whenever you take the square root, you have to remember it is plus or minus that square root. And root 20 simplifies to 2 root 5. Move that over, and I have my two values. Very similar for B, the only difference, I need to factor out that 3 from the first two terms. I need to move the 5 to the other side. This one's going to get a little ugly on the fractions, but the process here is the same. So 3 divided by 2 squared means I square the top and the bottom, which is 9 over 4. That gives me 27 over 4. So this becomes 3x plus 3 over 2 squared. And then common denominator, that would be 47 over 4. So then to solve, I would divide by 3. Square root both the top and the bottom. All right, when you square root 12, that can simplify. And now we're going to rationalize. So in order to rationalize, to get that square root out of the bottom, multiply by root 3 top and bottom. So I end up with the square root of 141 over 6 minus 3 over 2. So again, kind of messy on the fractions, but again, just understanding that process here is what's really important. All right, the last thing we're going to review is just how to use the quadratic formula to determine solutions. Now, hopefully you guys all remember quadratic formula from Algebra 1. But one of the things about the quadratic formula that you talked about was something called the discriminant. So what the discriminant is the thing under the square root. What the thing under the square root tells us is the nature of our solutions. It doesn't tell us what they are, but it tells us about them. So if that discriminant gives us a negative number, then there are no real solutions to that quadratic. Okay, that means what it's going to look like is opening like this or like this away from that axis and not actually crossing it. If there is one real solution, then the discriminant is going to be 0. If the discriminant is positive, there are going to be 2 real solutions. So all we're going to do in this last one is just determine about our solutions from the discriminant. So b squared minus 4ac is 9 minus 16, which is negative 7. Since it's a negative number, there are no real solutions. Same thing on b. So negative 10 squared minus 4ac, that gives me 100 minus 100, which is 0. Since I'm getting 0, then that means there is one real solution, and that solution will be the vertex. All right, so that is kind of your crash course review of Algebra 1 things for quadratics. Again, out of all of this, the most important thing to get is your factoring. Some of these are going to be a little bit harder than others, but the more factoring practice you get, the easier it's going to be.